All right, I think we're going to get started here. So welcome to our talk on studio-tested strategies, Perforce workflows at scale from small to large teams. We tried to win the award for the most words in the title of a talk, but I looked at the agenda and I found a couple that beat us, so we have something to aspire to for next year. All right, our agenda today, first off, my name is Brent Schiestl. I run our product management group and lead P4, P4 Cloud, and some other parts of the P4 portfolio.
And my name is Johan Karlsson. I also work as a product manager for our code review solution, as well as our DAM and our new product P41. So I will be following up after Brent here in the end and talk about some of the things that are kind of in the periphery around the core product that we have around version control. And I will also talk specifically about some tips and tricks when it comes to the code reviewing.
All right, so I'm going to start off here talking about server topologies. The very most basic server topology is a single server topology. This is what you get when you come out of the box installation with Perforce. Your single server is called a standard server, technically speaking. And then you have options to scale. And the scale comes with better performance, but also more management overhead. So you can see here, starting with a single server, a lot of times customers will then move to proxies, then eventually to forwarding replicas, and the most adventurous customers make their way to edge servers as well. So I'm going to talk about the differences between all these different types of servers and try to make sense of it for you. So again, where you start out of the box is a standard server. So this is a screenshot from our P4 admin tool. There's a new tab in there called topology. I can't remember what version you have to be on. It's probably 23.2 or something like that in order to have it enabled. But we draw this graph for you. Again, this is not a fun looking graph because there's only one server. But this is where you start, and it's a type of server called standard. Now, where most customers go next are proxy servers. So you can see here, again, using our topology graph, this is an example of 3 different proxy servers all connected to the same hub. In this case, you see the word commit. This could also still be called standard. It doesn't have to be called commit at this point. Why do people use proxy servers? Number 1, it's the easiest to set up and administer. Number 2, they cache files. So they do not cache metadata. They're not going to help you get information about branches or streams or about change lists or anything like that. But they are going to get the files physically closer to the end users. So your sync times are going to be benefited. Your end users are going to notice a speed up in the syncing. Proxy servers are ephemeral, meaning you don't have to have a separate DR strategy. If one goes away, there's really no harm whatsoever. There's no data loss or anything like that to be concerned about. And then they do have some built-in cache management functionality. We put in some abilities to define a last access threshold. So if you can say the number of days is 28, and if a file in the cache hasn't been accessed in the last 28 days, we can automatically purge it for you. I will say we could do better here. I think most of you say that's great, but I really want something that says if my proxy is 90% full, get rid of the oldest things in there and get it back down to a lower threshold. So we could do better here. We do have some options for you, room for improvement. All right, I also want to highlight that some of our customers actually like to set up a proxy for every single user. In this case, the graph is the same, only it's just one user per proxy. So this is another option that you have if you really want to get data as close as possible to the end user. Literally install a proxy on their same local machine that their client is installed on. So this works a lot where you have extremely geographically dispersed users. So you don't have pockets where you've got 20 users over here and 20 over there. They're just literally all spread out across the world. Kind of truly remote, no offices. And then what you can do is you can do scheduled data updates. So when that person is done working for the day, you usually know their work schedule. Then you go ahead and you go refresh the cache with the latest versions of the files that are mapped to their client. And now you're getting that data as close as possible to them, so that next sync in the morning is super fast. Also, you can ensure that your local data matches the server data. So if you want to avoid P4 clean, which we actually did some enhancements recently to P4 Clean, so it's not as bad as it has been in the past. But there are other ways that you can just wipe out the proxy and start over to make sure you're good and you're synced with the head server, if you will. And then also you can keep these servers tidy. So sometimes you can run a custom tool and clean out the proxy and just leave the latest versions. So these reasons actually came from a customer of ours where I was talking with them and they said, I actually set up a proxy for every single user. And that kind of blew my mind. I was like, I didn't know customers did that. So I asked, why are you doing that? So these were the reasons why this individual customer is doing that. Okay, so then moving on from proxy to the next one in the complication or the level of complexity chain is forwarding replicas. So again, here what you're going to see is that middle blue server can either be commit or standard still at this point, but forwarding replicas bring metadata into the mix. So unlike proxies where we're just talking about file content, now we're starting to talk about file content and metadata. But we are only talking about read-only operations. So things like sync and submit and others and revert are not going to be handled through that forwarding replica itself. It's still going to have to go to the upstream and do some coordination. So you won't benefit from all things, but read-only operations will benefit. You can chain them together. As shown in this picture, the forwarding replica 3 and 2 are chained together. The 3 is chained to 2, which is chained to the commit or the standard server. It is possible to do that if that is something that you find value in. And then again, ease of management. You don't need to have a separate DR strategy for each of these forwarding replicas because they are also ephemeral, just like a proxy server. All right, so then moving to the most complicated part of this one, you're going to see a bunch of edge servers in blue, and then each of those edge servers actually has a standby server because this is where you actually need to get into a little bit more complicated DR strategy. Why do you want to move to an edge server? Well, number one, some write operations like sync, opening for edit, resolve, merge, revert can all be done through the edge. It doesn't need to go back to the commit server. In this case, that middle server actually is a commit server. It's not a type standard anymore. So when you move to edges, you do have to take your existing standard server and update it to be a commit server. That is something to be aware of. You can chain edges together, just like shown at the bottom of the screen, just like you can do with forwarding replicas. But again, each of those should have its own standby server, which is the next point. Each of these should have a mandatory standby. Mandatory standbys are good for disaster recovery, and they have built-over failover. So we have P4 failover, and actually, if you're doing a planned failover, not an emergency failover, we also have a P4 failback command that not a lot of people know about. Some of our customers use the P4 failover with intention to fail back for how they upgrade their servers as well. And then last but not least, one of the what I'll call not so great things about edge servers is that the client is attached to each edge. So every user client is attached to an edge. The edge knows about it. And if you want to move a client from one edge server to another, you have to do this thing called unloading and reloading, which is not the most efficient operation in the world. I can tell you that the architect team, if I ask them to try to squeeze any more juice out of unloading and reloading, they're going to throw something at me because they're sick of me asking. But one thing that we are looking at doing is saying, in the future, a lot of this client information that's stored on the edge, that's unique to the edge, we're actually going to try to push it to the client itself. And so we're working on a very big POC right now where the end goal is to say we're going to take the requirement of unloading and reloading clients across edges completely away. Now, I can tell you that it's POC. If we make it, that's going to be fantastic because at that point you could say, yesterday John Doe logged into Edge 1 and his client was attached to that or was attached to that one per se. It was working off that server. And tomorrow I'm just going to automatically route him to Edge 2 instead, and there would be no unload and reload required. So that's the place we're trying to get to with Edge servers to make them better than they are today. Okay, so that's server topologies. I'm going to move on to branching and streams. So let me just go with where do you want to usually start and why are streams useful? Number one, a stream is like a branch. except when it's not. And the except when it's not part is things like import, import plus, being able to basically bring in content from another part of the depot into your stream. Also, we have functionality called stream components, where basically one stream can import another stream. So it's like a branch, just with a little different flavor. Streams define workspace views. So the nice thing about streams is when you set up a client, you just point it to the stream. This is helpful in terms of easing the burden of setting up new clients. And then they enforce merging rules. So we always talk about merge down, copy up as being the most useful pattern in branching and using streams. But when exceptions arise, we don't enforce it where you can't get around it. So if you need to do cherry picking, that's totally possible with streams. And then streams, we call them, have superpowers. The most recent one is something called sparse streams. I'll talk a little bit more about sparse streams in another slide here. The key thing is when you start, you should really just start with a single stream. So it's the easiest way to work. Everybody's working in the same stream. Then at some point you're going to say, well, I'm going to start doing some more experimental work. This experimental work could have the build breaking component to it. I'm less confident that it's going to build correctly the first time, and I don't want to be the one to break the build because nobody likes to be that person. So in that case, you'll probably move to a development stream, and you can see a dual arrow here for that merge down, copy up workflow. The merge down, copy up helps us to keep the main line stable. So you merge all the latest changes from main into development, you do all your testing there, you make sure everything's good. When everything's good, you copy those changes back up to main. When you do it that way, you're making sure that when you copy those changes back up to main, that you're not going to break the build. Okay? So in this case, work can be done in a dev stream, and there can be multiple people working on the dev stream. And then again, you copy up to main. At some point, you're going to hopefully hit the point of releasing code. And now at this point, you're going to add a release stream. The release stream is shown as being above the main stream just because it's a more stable code line. And in this case, there's only a single direction arrow. And that's because in this case, you don't want to be taking a lot of changes and bringing them back up to the release stream after you cut it. Because your release stream is really just a point in time artifact. This is what the code looked like when I pushed out this particular release. And then as you make new releases, you make new release streams. And again, this is a good reflection of a point in time. What was the code looking like at the time I pushed out a particular release? Okay, virtual streams are a thing. I don't really want to talk too much about virtual streams because we have something coming out in 2025.2, which is in November, that hopefully take a very big reason why you're using virtual streams today away. I'll just say virtual streams are just a filtered view of its parent. So if you have in today's world, a lot of people use them because I've got 6 people all working off the same stream, but they all have 6 unique needs in terms of what content they want from the stream. So we tell them to create virtual streams. And then this stream graph gets very cluttered and nobody likes it. So what we're doing is in 25.2, we're introducing a new field on the client spec called limit view. And so limit view is basically going to say, create the client, point it to this stream, but then exclude these paths from that stream. So now you can say every individual user gets their own unique view of this stream without having to mess with virtual streams. Again, this should be coming out in mid-November. Okay, and then last on branching is sparse streams. So one of the pieces of feedback which was very legitimate is for those of you, and probably everybody in the room, has experience with Git growing up and at some point in your careers. And then you come over to Perforce and you're like, oh man, branching was so cheap in Git, and then I had to use this thing called Perforce, and branching is not cheap in Perforce. And we heard you. And so what we did is we created 2 new types of streams. One is called a sparse dev for development. The other one's called sparse rel for release. And basically what we do here is say on the left-hand side, the traditional stream is you had to run this really heavy populate step. And so basically, I believe it's somewhere between 5 and 6 metadata records that we write into the newly created branch or streams namespace for every file in the parent stream. Some of our customers have upwards of 20 million files in their mainline stream. And if we're writing 5 to 6 metadata records for every single file, that's a lot of metadata. And then if you add edge servers into the mix, now we're replicating a bunch of data downstream, which is why that operation feels so heavy. So with sparse streams, what we do is we say, create this sparse dev stream, for example, and instead of branching any metadata, we actually don't branch anything at all. And we use something called overlay views. So we overlay a view to the parent stream. So your workspace makes it look like all these files are there, but actually if you inspected the depot, none of the files are there because no metadata was branched. And then only when you actually open for edit files in that sparse dev stream do we actually branch metadata. So it might look like more over time. If all I did was branch 3 files or open for edit 3 files, those are the only files that are going to have metadata populated in the sparse stream. So again, what we're trying to do here is say, we heard you on the fact that branching was very expensive, and we tried to make it much more cheap with sparse streams. All right, I'm going to hand it over to Johan, who's going to talk about code review.
Thank you, Brent. All right, so we brought bees for everyone that we would come here, and we clearly didn't bring enough bees. So I've been trying to get my colleague to bring another box of them. If you've been at other events, you probably are familiar with those bees. But how many in here are using Perforce today for version control? Can you raise your hands? Almost all of you. Great, great, great. I will be talking about code review primarily, but before I go into some of the weeds there, I want to talk about basically some of the rebranding we've done and the suite of products that you have access to. And since many of you are using this already, I think this can be good as a quick explainer as well, because many think of Perforce as just version control, but we actually do many, many more things. And this is what we call the P4 platform. So if you want to be like a true P4 studio, you could use code review. So this is a tool that used to be called Swarm before. So how many are using Swarm or code review? Most of you, okay, good. So that's where I will spend most of my part here. P4 DAM, we launched a couple of years ago now, but it's been maturing very quickly. It's our digital asset management tool that's also used for reviews of assets. So how many of you would say that you work on more of the art side of game development or whatever you do? Not that many, okay. So I'm gonna have 1 or 2 slides for you as well, so don't worry. P4 Plan used to be called Handsoft back in the day. A lot of things has happened with that product as well, but that's our planning tool. So for anyone who wants a scheduling tool or capacity tool, any producers in the room, that would be one to look out. I'm not going to cover that today. And then we have just launched P41. So P41 is our brand new client. So this is included for free with all of you who use Perforce today. And it's built to be sort of a alternative to P4V for those users who may struggle using P4V for various reasons. And we have focused very much on the kind of artist persona. So it's a very visual interface. You have local versioning there, so you could kind of go out on different experiments and track versions locally in what we call tracks. That's what you're seeing on the left-hand side there, kind of branches, you could say. And then when you navigate through your files, as you will notice, if it's an FBX file or an image, etc., we will show the actual visualization there. So yeah, that's what the kind of state of the platform is. And now let's get back talking about code reviewing. So 3 things we want to achieve with code review. Good collaboration, a lot of good learning experiences and ways of getting cross-team learnings of doing code reviews. Speed, of course. Many people associate code reviews with being something that kind of slows things down and things. I think you can look at it as really a powerful tool that in total is going to speed up your total development time. And then lastly, and I think the primary reason most people are doing code review, of course, is quality. And towards the end of this talk, I will try to give some recommendations. So just as a little bit of primer of how I think of context, because very often how we give recommendations, the first thing will be it depends. And I love this graph. It's called a Stacy graph for complexity. It's not something that I came up with. But basically on the left-hand side, you have how certain are you in your project, or how much agreement do you have around what you're doing, around your requirements? You know, simplest possible form, or do we all know what we're going to do, you know, what's in P4 Plan or in Jira or something like that? Or also do we know what's going to make this game fun, for example? And on the right hand, on the x-axis, we have how certain are you with the technology that you're using to deliver this project. So if you're extremely far from certain how you're going to do something, and you're very far from certain what you're doing, that's when it gets very chaotic. So this could happen in normal projects as well. So one example can be, it's a day before the release, QA comes up with like 10 serious bugs or something happened overnight with the build. And it's like, are we agreeing on what we're going to do with these bugs? Someone exec might say, no, we have to push the game. Someone else might say, we have to fix all of these, etc. So you're having to pretty quickly come out of that chaotic situation. Next up, you come into a more complex scenario, and that's where I think most of game projects happen most of the time, where there is some uncertainty in one of these domains. There's something you're trying to discover. Normally, this is why, Scrum and Kanban and methods like that has become so popular, and there's a lot of good things you can do with code review here as well. We have a complicated scenario, which is typically more when things are more, we have agreed on standards. We kind of have agreed on something we need to comply with, something we need to do. It becomes a little bit more plan-driven at that approach. I see a lot of art teams tends to be in this kind of a domain. And then lastly, when it's super, super simple, you know exactly what to do. You know how you're going to do it. You've done it 100 times before. It's really just a checklist thing. Like things can be really, really efficient when it comes to code review. So a project, of course, moves between these phases all the time, and different teams are in these different phases. So I think that's where I want to come back to in the end and just talk about this more from a code review experience and how it can be good to use some of the flexibility that we offer. But all right, you already made it quite far now with very technical slides. I just want to talk a little bit about collaboration, because the benefit with my job is that I meet a lot of different companies, and I can kind of see when we interview users and things, how they do code review. And collaboration doesn't really matter about what tool you have. But I thought, I assume there will be a lot of game developers here. So I'm kind of thinking that when you're doing code review, what is your review character? This is like an adventure we're going out to when we're doing code review. And I kind of find some kind of people that on the left-hand side here, they're kind of the good characters. If you have these people in your team, your code review experience in Swarm or whatever tool you're using is going to be really nice. And if you have the people on the right-hand side, it's going to make it really hard. So let me just quickly go through this. So a mentor, that is someone who teaches and kind of helps, especially junior devs, to do a better job. So if you are a mentor, you ask, why are we doing this more than, what are we doing? If you're an architect, you look more at the big picture. You typically miss, maybe some small details in the code, etc. But you think about how is this code going to scale, let's say 6 months from now or 10 years from now or forever, how long you think about your product. A speedrunner, that's the one who's always first on every review. As soon as you get that notification, they open up the review and says vote up or vote down, gives you some quick feedback. A playtester, that's the one who would actually try to run the code and try it out, open it in the engine and things like that. Really try to think more from almost like a QA's perspective from the beginning. And then we have the gatekeeper, typically the least liked person, especially by those who always get denials. Like, hey, you haven't followed the coding standard here. You haven't complied with X and so forth. And if you have a group, if you have a team, so if you're a team of 5 and each of you pick like one of these characters, you're going to have a really, really high quality code review process. But then you have these bad guys on the right-hand side. So I don't know if hopefully no one recognizes these. But the coward, that's the person who always follows what other people are doing. They never contribute anything to code review whatsoever. They wait until someone else votes up and then they go in and vote up. The ostrich here, that's a person who just ignores it completely, never want to contribute, just want to do their own work without helping or looking at something else. And the scope creep is someone who would just add extra work. Oh, while you're looking at this code, why don't you also do these other things? So even before we start talking about what code review we offer in terms of code review capabilities, really think about what are the review characters that you have on your team, and if you're missing something, can we pick something up and can I cover some of those characteristics? And then you have your character. Next up, pick your weapons. So these are more some general recommendations on what's needed to have a good code review process. So on the left-hand side, those are things that you need for as a kind of author, the one who's actually writing the code. You have to keep your review small, of course. If you can offer a map, if you can tell people, why have I done this change? Why have I chosen to solve it this way? You have your change list description, but you also have a review description. And we have added a lot of capabilities. You can add like images and stuff if you want to, like as attachments to the code review side. Then you've done your work as the author of code. So then for the actual reviewer of code, well then, use a stopwatch. Don't spend hour upon hours to understand something. Gate something, and if you still don't understand it, it's time to start asking questions. The other things, I'm not going to go through all of them, referring to the guidelines and so forth. But I think towards the end are two very important ones: to review with respect and empathy, and balance criticism with positive feedback. Because sometimes we get like feature suggestions that indicate that you're not really friendly to each other at all times when it comes to code reviewing. So remember that when you're doing that. So that's two things about the collaboration. Think about your character and think about what tools you're bringing to the code review. Now, let's get back to some more technical stuff. Speed. So 3 parts to speed up your code review process. First, automation and builds and so forth. So we have, I don't know if you've seen that in code review, there's an option called tests. These are almost like webhooks, actually. So what you can do in code review, and it's in a UI, I'll show you a screenshot in a second. You just define a URL and a body, and we have a templating language, and you define this test, and then you set up an endpoint somewhere else. And this could be in your build server, it can be a test system that you have, or a custom service that you run that's going to receive those test executions. And then we expect a pass or a failback, and you can include messages and things like that we will then surface and show in P4 code review. And these can be automatic or manual, and they can also be enforced, so to say, so they need to pass. So looking at the screenshot, you're not going to see the text here, so don't worry about that. But you do all of this in the UI. So automating things in P4 code review is relatively straightforward to try out. You set up your test, you tie it to your workflow, so that's where you can see all the arguments and things you have, and then you get a quick feedback immediately into the tool, which has passed, which has failed, and then you have options there if you're going to allow to rerun them manually and so forth as well. We also offer a number of ready-made integrations. So there's Jira, there's TeamCity, there's Jenkins, and we also have a REST API that we know many people are using for various integration needs. And now you haven't heard the word artificial intelligence or AI for almost 40 minutes, I think, so apologies for that, but here we are. So we also have to mention what we're doing when it comes to AI. And in P4 this week, we're going to launch an MCP server. So it will give you a lot of options and when it comes to integrating and sitting in Visual Studio and asking for things to be versioned and things like that. So this will be open sourced. It will be published, did we say tomorrow? Hopefully tomorrow, yep. And on the code review side, this is also an area where we have found a lot of opportunities when it comes to AI. And there's a lot of kind of shortcuts that AI offers. So we have launched our first feature, which relates to actually the reviewing side of code review. So we know there's a lot of AI tools out there already focusing on the kind of when you're writing the code. But we have started to deliver a number of capabilities when it comes to how we can support the actual reviewers of the code. So right now you can select any code in code review and you can hit the AI button and it will give you back some explanation and help you get started with it. We are releasing very soon also some improvements when it comes to the comments and the tasks, so that when you're writing a comment, you can get help with spelling or improving the comment and those kind of capabilities that you would be expecting. And next up, we will start to work on the review process itself. So as soon as an author requests a review, the ability to do pre-review checks. So an AI can check specific things that you would like it to check to help automate and give you quicker feedback for some of those reviews that are not possible to automate without AI, so to say. But that's coming sometime next year. So to speed up your review process, automate as much as you can, use the integrations that we have, and then start discover if any of these AI capabilities are useful for you. I will also mention that these AI capabilities will never be sort of mandatory or you have to use them. They're turned off by default. We're choosing a model where we integrate with various models, so you can also free to choose if you're working at a studio, you have developed your own models, for example, etc. All right. Next up, let's talk about maybe the most important part of code review, the quality. And I think the first thing you should really think about how you're using P4 code review is how do you define your project. So that's really the foundational step of what you have in code review. In P4 code review, it's really just a set of branches that you define a project, and then you tie that to some rules and some people. In many cases, people make it relatively simple. They put a stream family, and I think many also create maybe one depot per project or similar. So they map their project to a stream family. Clean, simple, straightforward, especially from an admin standpoint. I think that's how many people do it. I've seen many cases, though, where people choose another approach. So they decide that, well, let's split up. So our actual project, I'm going to split it up into, let's say, 3 or 4 or 10 projects in P4 code review. So it could be that one of them is where I put, my feature teams, and they work in the streams or the paths that they're working in, their mainstream and dev stream maybe. My tools team, we put them somewhere separate. Maybe we set up one of these private projects that we offer. So you have anything that's sensitive or code that really no one should touch, but if someone touches it, we're going to ensure that the right people are looking at it. So you have this kind of balance there between like having just a single project and having a lot of projects. And what this really impacts is when you make a change. So this is someone who added a couple of files. Who's going to look at it, right? Automatically populating so the right individuals and groups are there. And also ensuring that the blocking approval, I don't know if you can read that at the top right. What is it that needs to happen for something to get approved and allowed into our mainline, for example? So that's really what I'm talking about. How do we define that, and how complex do we have to make that automatic population of users? So to summarize the kind of high level how I would do it normally, a good way of doing it is to think about your production code and your critical systems as a separate thing. That's one project, because that's really where you want to have that quality focus. Whereas if you're doing rapid prototyping or having like non-critical scripts and tools, don't avoid code reviewing just because it thinks you slow you down there, but use just a different model and put that in a different project. So those kind of changes can follow different rules that allows you to move faster and to help you collaborate. Maybe you use other automations there, and probably you're also going to use a post-commit review process for that, potentially. On the left-hand side there, we're talking about the pre-commit review model. So I just want to briefly talk about some of the differences here, because this is, a lot of studios are mixing using that. So the pre-commit review model means, of course, that before something goes into your mainline, for example, you do make sure that the review is approved and it's completed. And this is very good because it ensures that it's a stable code that we're working with at all times. You have very low probability of breaking something, actually. It works very well with also running some of these integrations with Jenkins and so forth to ensure that things build before it makes it into the production code. But it can also be considered a slowdown. So that's why I think it's important to separate your projects out, so that for the things where you need to move much faster, you don't let this pre-commit review model get in the way, so to say. And I also have a note there in the bottom left about it's probably especially good for code plugins and essential functionality blueprints. Post-commit review models, that means you can make your changes, you can put it in your code, you can run it and test it and all of that, and then the review can happen whenever it is convenient. So much more faster paced. You can review immediately, or you can choose to create the review much later. It's of course going to lead to more problems potentially, and it might in some cases be a better fit for art. And the pre-commit review model, if for anyone who's new to Perforce, but most of you were using this already, it depends on something called shelving. So if anyone is wondering, well, how can we have a central version control system and we can have everyone sharing code and so forth and reviewing that without it actually impacting the central code? Well, this shelving works in that way that when you create a shelf, we put it among our shelves. So we have A, B, C, D, 4 files here, and we made changes to B, C, and D, but that is still not being submitted into your mainline. So in this case, B and C was approved with this green checkbox, and file number D failed, so that's not something that ever going to make it into the mainline. And then you can have a submit either from code review directly or via some other script or from P4V into your mainline as soon as something gets approved. So that's the magic behind how we do this pre-commit review model in P4 code review. All right, so quality, last part here about that. Now, these rules. So you have your projects, we divided that up according to the criticality of the code. And then there's a lot of functionality and flexibility in P4 code review to determine what should it take. And I think these are like 5 basic questions to ask, where can you approve your own code? In general, that's a bad idea, right? So you set up a rule to say you need at least one other set of eyes to look at everything. Are there specific people that must approve of it? So this is where the branches setup and the project setup can become very valuable, because of course it normally is the way, well, there is someone who knows this code really well, but may not know other code very well. So we can use this separation of branches to make sure that if someone changes this code that the developer Joe knows extremely well have written, developer Joe will always have to look at it, right? So that we call that a moderator. Should there be any open unresolved tasks? Normally that's a no, right? We want to make sure we reach a resolution to everything, so that's something we can enforce. Automatic test results that need to pass first, also a good thing to have if you can do that. And other things you can do. So there's a lot of possibilities here to make sure that you can vote up, because that's one thing you can do. You can make a vote, cast a vote on a review. But what does it take to actually approve something? So the simplest possible thing is just to say, hey, we require a minimum upvote of 1, and it can't be yourself. That's like the most basic rule system you can have, I think. And still then you have probably improved quality quite a bit if you're not doing code review today. All right. So putting this back into the context then that I mentioned in the beginning. If we're looking at a chaotic system project where you're just starting to in that you really need to get in control of some way, I think that you can really use pre-commit reviews to get in order. You force a system onto something chaotic to ensure that you reach alignment in one of these directions and get out of that chaotic situation. And if you're in a complex scenario, and this is where I think, as I mentioned initially, a lot of game projects are most of the time, it's very powerful to utilize both the pre-commit review model and the post-commit review model. And I highlighted there also that this mentor and this architect person, they can really use code review to share knowledge and to ensure that you're building a stable system. So you use, once again, the pre-commit system for your critical software, and you use the post-commit for the less critical. But you make that separation, because that allows you to both run fast where you need to run fast, but also ensure that you're getting so much structure, so you're moving down into something that is easier to manage and going to give you higher success. If you're in the complicated scenario, this is where I think I find many of our customers outside of game development. Actually, many people have a lot of regulatory needs they need to comply with. They 100% use pre-commit reviews for everything that they do. And then once again, if you're in that very, very simple checklist approach, you're in a project or a way where it's actually very straightforward. Everybody knows what to do, and we know exactly how to do it. Well, why let the code review tool slow you down, right? Why not move to a post-commit process so you can make sure that you can run as fast as you can with that simple model? So that's a summary of things I wanted to share with you today about achieving speed or collaboration, speed and quality with code review. And for anyone who's doing art review, I want to mention that DAM has kind of opened up the similar capabilities, but for digital art assets. So one of the main differences I found, at least coming more from code review side now being more and more involved in art reviews, is that there's a very fundamental question being asked all the time. What is an asset? What is it that we're actually reviewing? Do we have everything that we need to review? So one of the major differences with this tool is that you have this concept of what we call an asset bundle. So it allows you to group things together that don't necessarily live at the same place in the depot. So it could be both kind of your working files and your renditions and your materials and textures and other things. But you can put them all together and you can create a review where you actually set up, now I actually want to review this whole piece as a whole. And you can add context to that and metadata and links to other sources. And then, of course, you have this kind of abilities to draw on stuff and on 3D models and images and some of these file formats to help that. All right. So you all qualified for the beast now because you stayed to the end. If you want to learn even more about what we're doing, we're having a booth here. We're also having a webinar about a mid-year update. So if you want to listen to something more that we do, you can scan that code. And otherwise, we're going to open up for questions and say thank you.